Hello everyone. In this question, we have four different problems, and in each problem, they have asked you to find the value of A, B, C, D, which has been specified in small letter. Yes. So we'll move on to the first question. Yeah. So by seeing this question, I am getting two property. So what are the two property? Let me discuss. So see, this BD is a chord. It is passing through the center. Whenever a chord is passing through the center, it's nothing but the diameter, which is the longest chord. So angle subtended by the diameter is always 90 degree. This is one property in a circle chapter. So it's going to be 90 degree. And then I am getting one more property. What was that? AB is a segment. Both angle C as well as angle D. That means both C and D are subtended by the segment AB. So we know one property. The angle subtended by the same segment will be always equal. So if this is A, this is also A. So for me, it is very easy to find the angle D. Why? Because we can consider triangle ABD. In that we know the value of angle A as well as we know the value of angle B. So only we need to find D. So A angle is 90 degree, 90 plus 35, it's going to be 125. If I subtract 125 from 180, we will get the angle for D, which is 55 degree. So here the angle D is equal to 55 degree. So whatever the angle D, it is same as that of A. So here at vertices C also, the angle is going to be 55 degree. So what is the value of small a? It is 55 degree. So the first question is over. Now we will move on to the second question. Yes, so I'm looking for the diameter, but see in this question, the chord AB is not passing through the center. So we cannot consider that as a diameter. So as of now we'll leave. But another property is there. See, both angle C as well as angle D. That means the angle made at vertices C as well as at D at this point and this point, both are equal. Why? Because both are from the same segment. So here also it is B only. Yes. So now we need to find the value of B. Okay. So yes, I can mark this point as E. So can I consider BCE as a triangle? Because we know this angle, that means EBC as 25 degree, and we can easily find this angle because linear angle sum property. AC is a straight line, on the one side 120 degree, then this is going to be 60 degree. So if I use the angle sum property for the triangle BCE, I can easily find angle C. If I know what is angle C, that is equivalent to angle D. So over here it's going to be 180 minus 60 plus 25 is going to be 85. So if we subtract, we will get 95 as an answer. So at the C, the answer is 95 degree. So B is equal to 95 degree. At the vertices D also, same angle 95 degree. Hope you understood. Now we'll move on to the third problem. By seeing this problem, I've got one property. So what is that now? Angle subtended by the chord to the center of the circle is going to be twice the angle subtended by the same chord to the circumference of a circle. So here it is on the circumference, it is making 50 degree. From the same segment, AB is the same segment, it is making two angle at the center as well as on the circumference. So at center is always going to be twice the angle at the circumference. So this is going to be 100 degree. Now, when you look into this OAB triangle, here side OA and OB are equal. Why? Because it's a radius, right? From center to the point on the circumference. So if this is an isosceles triangle, then whatever angle over here, the same angle only over here also. So we know this angle, that means AOB as 100 degree, then remaining is 80 degree. That 80 degree has been split into two equal half, which is 40 degree and 40 degree. So what is the value of C? It is equivalent to 40 degree. This is the value of C. Yes. Now we will move on to the last question. So over here, yes, here the diameter has been given. So AOB is a diameter. So I can mark angle P as 90 degree. Yes. So anything else we can find over here? Yes, PB is the same chord. See, if you see, BP is the same chord, making angle at C as well as at A. So these two angles are equal. So if angle C is going to be small d, then at angle A also, at vertices A, we are having one more angle now, that is also going to be D. So here, how can I find D? Yeah, we can find by considering the triangle BPA, because we know the value of angle P as well as angle B. Just we need to find angle A only. So what is P? It is 90 degree. 90 plus 45, which is 135. So if we subtract 135 from 180, so what we will be getting? So the answer is going to be here, it is 5 and 45. So 45 is the answer. So here it is equivalent to 45, and here also it is equivalent to 45. So small d equal to 45 degree.